Hello, everybody, and welcome to today's lecture where we talk about trucks and hauling equipment. So let's get started. All right, so trucks are a very cost-effective hauling equipment due to two reasons. One being their relatively high speed, and two being their relatively high capacity. So they can travel fast and they can haul a lot of load. So they are very popular in earthwork operations. So the productive capacity of a truck will depend on two things. One is the size of the load. Obviously, it can change how many like cubic yards you can process per an hour. And number two are the number of the trips a truck can make in an hour. Okay, so based on the size of the cargo box and the number of the trips, you can have an estimate of how many cubic yards of load the truck can haul in an hour. So there are some limitations. Even though your truck has a lot of capacity, it doesn't mean that it can move on any highway, because highway have some load limits that you have to comply. And also there are some truck weight capacity. Okay, so it means the truck cannot get heavier than a certain number. That's why you are limited by those numbers, even though volumetrically you can load your truck uh, for a higher number. So the number of trips completed will depend on the speed, the travel speed. Obviously, you need to, if as a hauler, the truck has to travel and then get loaded and then travel back and dump the load. So the speed travel um, is an item. And of course, the loading and unloading time is the second item of a cycle time. Okay, so the cycle time, basically, it is the dumping, then going to dump the loading, and then traveling to unload, and then dumping the load, and then returning to the initial situation or location. So the number of trucks is a big question for a contractor or for a project manager. They're interested to know how many trucks they would need. And the best case, the optimum condition is where your loading and your trucks are balanced in a way that your loaders are working at all times and your trucks are working at all times, or your equipment don't sit idle because you're paying for them. So the effectiveness is where you have your equipment functioning at all times. So tires are a very expensive part of the trucks. They include 35% of the maintenance costs of a truck. So you got to be careful about your tires. Taking good care of the tires is primarily dependent on the amount of load you put on your truck. Okay, on your truck. So that should also, the amount of load should also match the site condition. Capacity of the trucks and other hauling equipment could be presented in three different ways. Gravimetric, it means the load, like if you weigh the load that is on the cargo box, how much will it weigh? Okay, so this is about the load. But they could also be computed based on the volume. In that case, we have two different situations. If you remember, it's the same story we had for filling the bucket of a loader, right? So the cargo could be considered a struck volume, and that's when the load is at water level with the top edge of the cargo box. Okay, so however, you can go for more. It means you can load your truck with the heaped volume, and that's when uh, you'll have extra load on top of the edge of the cargo box, and in that case you will have a 2-to-1 slope above the dump box, and it will look like this. Okay, so um, there are tables that tell us the volume in different status, in different situation of stock and heaped. And if you take a look, 55 versus 79, it means heaping the truck can significantly increase its capacity, or 42 cubic meters versus 60 cubic meters. Okay, so as you can see, it's almost 50% more. So it's, I mean, the heap volume is significantly, or can be significantly higher than the struck volume. All right, so does that mean we should overload the truck as much as we can to make it cost effective? There are some reasons that tell us why we should not overload a truck. Number one is that when you overload a truck, there will be a lot of pressure on the tires, and this will create extra temperature on the tires. When that happens, the tires will get a permanent damage. Okay, so the tire will have a permanent damage. Obviously, when this happens, the operating costs of the tires will increase. So also, to add some capacity to your truck, you could heighten, or you could increase the height of the sideboards. Okay, so sometimes they are adjustable, or they are removable, replaceable. You can add some sideboards to increase the depth of the cargo box, and obviously the capacity of your truck. When you do that, there is a limit for doing that. You should be careful that the weight of the volume does not exceed the vehicle's gravimetric load capacity. So in some trucks, the manufacturer will provide you with some detailed information about adding or removing the sideboards, and the maximum amount of load that is allowed to have on them when the sideboards are added. So if the added weight is greater than the gravimetric capacity, then most of the time your solution is not cost effective. It means although you are adding to the capacity of your truck, you're not being cost effective. Why is that? Because you are adding some fuel, you're adding the fuel consumption, you're adding the cost of reduced tire life, because your tires will wear out sooner, and frequent failures of the machine. For example, the axles, the spring brakes, uh, springs, brakes, not spring brake. So springs, brakes, and transmission all could wear out, sooner, and that's additional cost for you. But sometimes the additional cost on tires are marginal, while the loading of materials, having loading higher amount of materials per trip could significantly lower your costs. So that could justify the additional cost you are spending on tires. Okay, this is especially true where the hauling distance is long. Okay, so you want to decrease the number of trips by increasing the volume that the truck is moving. So it could make more sense to increase the volume and be ready to pay the cost of, tire wear, and in return you could decrease the number of trips you need to make, and obviously the cost of hauling. So keep in mind that tires are about 35% of a truck's operating cost. That's huge, right? More than 1/3 of operating cost for a tire, for a truck, are for its tires. And overloading a truck abuses tires. So these are the two important elements about overloading. So many times you ask yourself the question of how many trucks, or should I use smaller trucks or larger trucks? Obviously, the number of trucks will depend on the capacity of each of the trucks. Obviously, if you have larger trucks, you will need fewer number of them. But there are some disadvantages with each of the choices. Let's take a look at the disadvantages. If you have a small truck, obviously you will need more trucks, and that will create labor cost for you, and loading. There will be some issues with the loading because small target for excavator operator will be available. Yes, it's a small bucket, and the excavator operator will have to spend some time to adjust the bucket when dumping the load, or when loading the truck is happening. Well, where you have a big or very large cargo box, then the excavator has a lot more freedom to dump the load, so it could increase the cycle time. Okay, so I'll let you read this chapter. This table. It explains some of the advantages. Let's take a look at some of the disadvantages of large trucks. So loading time for them takes longer, especially with small excavators. So although you are spending a lot of money to use a bigger truck, the second truck has to keep waiting. I mean, the truck that is behind the one that is getting loaded, it has to keep waiting for a longer time, because if you don't have big enough loaders that can proportionally decrease the time of loading. Does that make sense? So it means, let's say you have a very large truck, but small loaders, okay? So they have to dump a lot more number of buckets to fill the truck. And you're not working with only one truck. There is a line, there's a queue for trucks. And the second truck and the third and whatever number of trucks that are waiting for the one that is getting loaded will have to wait for a longer time, okay? And you're paying for those big trucks. So this makes the process not cost effective. All right, let's do a problem together now. It says a loader operating at 107 cubic yard per hour. Okay, so that is the cycle time of the loader, not the truck. Okay, so first we need to find if you are matching the number of trucks. If you're given the responsibility of finding the efficient or the cost-effective number of trucks, the first thing you need to do is to find the loader production. Here it is given to us as a 107 cubic yard per hour. So it has a 2.5 cubic yard hipped capacity bucket. So we know that in each time it unloads, or it loads the truck, let's say, like that, it will unload 2.5 cubic yard of materials. So it has a 1.2 minute load cycle. Okay, so it takes more than a minute um, for the loader. I mean, for the load cycle of a loader. The trucks have 11 cubic yard capacity and a 30-minute dump plus haul plus return time. Okay, so we have all the elements of the cycle time for the truck. We have the elements of the cycle time for the loader. 95% fill factor applies to the loader, so not the entire 2.5 cubic yard capacity will be utilized. 95% of that will be utilized. And the project works 50 minutes per hour, so we consider 10 minutes in each hour not efficient minutes. So first, let's solve this problem together. First, you need to find the number of buckets that can fill one truck. Okay, since you have the capacity of the truck cargo, which is 11 cubic yard, and the capacity of the bucket, which is 2.4, by dividing that, you can find the balanced number. Okay, it means how many buckets in each cycle you're using. That's 4.4 if you do the math, but you round it down to be on the safe side. So let's say four buckets, and that compensates for the fill factor most of the time when you round down. Because yes, you might say only 95% of the bucket is getting filled. Yes, but you round down. And also, in another part of the problem, we take 95% into consideration. I'll show you that in a minute. So loader cycle time. The loader takes 1.2 minutes for each bucket, and we know that we are filling 4 buckets, or we are unloading 4 buckets. So that would take 4.8 minutes for 4 buckets to be unloaded, or to load the truck. Truck cycle time will be the loading plus hauling plus dumping plus return time. That would be 1.2 minutes plus 4 buckets. We already found that up here, so we know 4.8 minutes is is the time it takes to load the truck, and the haul plus dump plus return was given to us as 30 minutes. So if you add them up, a cycle time, one cycle of the truck would take 34.8 minutes. Okay, so the truck payload here is where you consider the fill factor. Okay, so yeah, we had 2.5 cubic yard size bucket for the loader, and there will be 4 buckets. In one cycle you could do 4 of them, but with 95% of the bucket filled. Okay, so this is the amount that you are hauling in every cycle by your truck. Okay, you are having 4 buckets, each one being 2.5 cubic yard, but 95% of your bucket will be filled. So the entire amount in one cycle for the truck would be 9.5 cubic yard. So truck production is how many cubic yards you can haul in each cycle, right? So you can haul 9.5 cubic yard per cycle. Okay, how many cubic yards you can haul per hour will tell you your production. So in each cycle you can do 9.5, and each cycle also takes 34.8 minutes. Okay, so you should divide those two numbers, and you should not forget the adjusting for efficiency. Only 50 minutes out of 60 minutes is being efficient, so you multiply it by this number that will reduce the production because of losing 10 minutes. The answer would be 13.7 cubic yard could be hauled by this truck in every hour. Okay, so that's the production. Now let's balance the number. Okay, so we found that loading takes 4.5 minutes, 4.8 minutes. Okay, to be precise. And the entire cycle time is 34.8 minutes. Okay, so if you do the math, it takes 7.25. You round it down because it's close to 7. It takes 7 trucks, 7 trucks to, to match the loading time. Okay, to match the loader. So each truck added to the job will increase the production for 13.7. Why? Because we just found it here, up here, that each one truck can do this amount of load in every hour. Okay. However, the loader will control and limit the total job, right? So if you have a lot of trucks, the loader will not have enough time to load them. Okay. So we just try different numbers. Let's say if we have 6 trucks, okay, if we have 6 trucks, we will be doing, each truck can load, can, haul this much of load. And if you have 6 of them, this is the entire amount, total amount you can haul per hour. Okay. And if you go with 7, that would be this much. If you go with 8, that would be this much. Okay, so as you can see, we found here number 7 to be the optimum number. Why? Because after you pass 7 trucks, it means once you reach 8 trucks, then the amount that need to be loaded on the truck is 109.6 cubic yard per hour. Okay, we know that the loader can only do 107 cubic yard per hour. Okay, so your trucks will be useless. The additional trucks will be useless. So this is a very fundamental thing in earthwork operations, to find the number, the economic number of trucks in a way that both your loaders and trucks are busy at all times. It means the loader is the controlling one. The loader should always have a truck in front of it to be loading it. Okay. If your loader stays idle, it means something is wrong in your estimations. Okay. So this part was important. Actually, we found the number of trucks here. What we did is that we found the production rate of the loader, the production rate of the truck, then by dividing the production of the truck by that of the loader, you find the number of trucks and you round it down, so your trucks will not sit idle. And then you just checked it. This is not in fact a part of the problem. We just checked what will happen if we pass 7 trucks. Okay, so it would be between 7 to 8, but if you go with 8, you will that will exceed the the capacity that the production of the loader. So it means your loader will sit idle with 8 trucks and more. And that also means with 6 trucks or less, your trucks will sit idle. Okay, it means the loader is busy with the previous one, and the second truck has to wait for the loader. All right, so let's talk about truck safety as the last part of this lecture. It makes sense that you do a hazard analysis or assessment every day, because every day your site condition might be different depending on the people, depending on the equipment, the congestion you have on the site, and depending on the operations you're doing. So you should ensure that the operations and operators and the drivers are aware of the hazards. Okay, for example, today we are doing this operation at the north side, or the soil stability could be compromised due to XYZ. Okay, so you should explain that for the operator, for the driver, so they have a good understanding of the hazards on every day. I mean, every day that they are on the job site. So ensure berms are adequately built to prevent truck from exceeding boundaries at dump locations. Yeah, so that's also an important thing. Ensure that the heavy equipment operator follow the operating signals. For example, if you should provide, actually, especially in big projects where you have a lot of drivers, okay, it makes sense to put some signals, put some signs for your drivers to, know what they have to do. For example, in many projects, the trucks have to wash their tires before leaving the job site. So you could put some signs to make sure that that thing gets done. Look at this guy. So use a spotter when backing heavy equipment. Obviously, for all the big equipment, there is large blind spots, and the driver or the operator might not see the people who are working behind. If the people working behind many times cannot hear an equipment is backing up, because the construction site is normally a very noisy site. Okay, so with all that noises, you have no knowledge. I mean, you don't know, you're not aware that a big piece of equipment is approaching you. So spotters are very important, and most of the time they are there. They are in place. So ensure that employees stay out of vehicle travel paths. Yeah, that's important. Make your paths as clear as possible. It's not possible at all times. It's not always possible to do that. Sometimes you have to keep people because they're busy with something, but do your best, do all you can to to clear your paths from humans. Wear high visibility safety clothing, so especially when the sunset time is early. For example, in the winter, you might be working a night shift, so you want to make sure everybody can see everybody. That's why wearing high visibility safety clothing matters. So that completes our lecture about trucks. I see you guys next time.